Hello, everyone. Let's do some homework questions together. We have studied derivative for the past week, and from definition to find derivative to applying the law of limit of derivatives. Now it's time to study how to apply these rules and laws to our homework questions. First of all, we know that I have this window, have three areas. We have, this is my assuming this is my blackboard, okay? And this is the flashcards, and these are the homework questions. So please have your paper pencil ready with you. And this is one of those follow me sessions, and I try to control time within like 20-30 minutes, and then we're gonna do another section. Derivative of a constant, of course, we know is zero. When we look at our homework, right, number 3 and number 4, these are constants, right? E to the power 5, E is a constant, to the power 5 is a constant. And 3 is equal, for number 3 equals 2 to the power 40. And that's constant, right? So it doesn't matter. So when we take one, for example, f of x, I make the fonts a bit larger. F of x, if it equals to e to the power 5, okay? Or the other one, the derivative, you can write it this way, f of x, f prime equals to 0. Done. You're finished. All right? Number 5, number 6, you see they're similar types, right? So we got constant, the derivative of constant is 0. The derivative of x squared is 2x, the derivative of x raised to the power n. We look at these power rules, we need to understand the derivative of x raised to the power n, when we differentiate with respect to the base, okay? So let me write it down here. The derivative, okay, that's x raised to the power n. Oops. X raised to the power n. Okay, we derived that definition in class. So we have n times x raised to the power of n minus 1. When we apply this formula, right? Of course, this formula apply for n equals to, let's enumerate the cases that the power rule applies, right? Let's enumerate some cases like this. I'll make some more rows, right? So when I probably should make another column, okay? Insert another column. So when we apply this power rule, right, it applies for different n values. And in this situation, you need to understand that the base is being differentiated with respect to. In other words, in the definition, okay, in the definition of limit, derivative, right? In the definition of derivative, limit, right? And this was h approaching 0. And this is h. This is f of x plus h, subtracting f of x. Okay, we know there's another form. So this h is basically x plus h minus x. Okay, so I'm putting a note here. So h is equal to x plus h subtract x. Okay, so let me make the font just a little bit smaller so we can have more stuff on one screen. So what I just mentioned, differentiating with respect to x, meaning x plus h minus x is h. So it is the change of x, okay, change of x. So I would also remind us of the other notation we once introduced called delta x, okay? Delta x basically is another way to specify that everywhere h is replaced by delta x, which is this is going to make it even more obvious that we're differentiating with respect to x. So when we see this formula, right, this x, okay, dx refers to delta x. So it means the change of x, okay, the change of x. So remember this difference, remember this distinction, right? And the power, right? We're differentiating with respect to the base. The power is a constant. The power is a constant, okay? So you can see it uses a different symbol, n. This different symbol, n, by using a different symbol, tell us that n has nothing to do with x. So relatively to the changes we're making, n is viewed as a constant. So let's look at some of the situations here, right? If n equals to 2, right, we're differentiating x squared, right? We're differentiating x squared. So you just plug in the numbers, right? N is 2, right? Differentiating with respect. So this is 2, and this is a 2, and it's going to be 2x, right? If n equals to 3, we're going to apply the same formula, n equals to 3. So this is 3, 3, and in the end, we get 3 times x squared. Oh, it turned out we don't need this column. Not yet. Okay, so this way C is better. Can n be fractions? Yes, n can be any number. N can be any number. It can even be 0. Yes, n can be 0. What happens if n equals 0? When n equals to 0, right, we're differentiating n to the power 0. N to the power 0 equals to 1. The derivative of 1 is a constant, and that is equals to 0. Okay, n can even be 0. N can be fractions. Okay, n can be fractions. N equals to half. Okay, this is the case that we see very often, which is a derivative of square root of x. N is half. Okay, well, n is half, and this n is half. And x raised to the power of half minus 1. Okay, of course, half minus 1 is negative half. There. So half minus 1 is going to be negative half. Negative half. Okay. So if you want, this is the derivative of the root x. So there's another form. Let me bring this down. Okay, let me bring this down. So this will be equal to 1/2 1 over square root of x. Square root of x. Okay. Here we applied some power rule. Okay. Here we apply some power rule, and the power rule. What are some of the power rules we apply here? So the power rules we applied here would be that b raised to the power of negative, say, k equals to 1 over b raised to the power k. Okay, the algebra, the rules from algebra. And also the exponents, right? So this is also the derivative of square root of x. Right, so just get familiar with these notation. I know a lot of you guys haven't touched mathematics for some time. So this is the opportunity that we can review our algebra. And also that if we have a base raised to the power of a fraction, right? I'm going to use m over k. Oh, k over m. Let's do k over m. Okay, this is a symbol. I don't want these symbols to confuse you. How about we just put a different symbol, right? I'm going to use a heart. I'm going to use the denominator of this will be using, I'm going to use which symbol looks nice to me? I'm going to use spade, right? Okay. So when we have expression like x raised to the power of a fraction as exponent, in this fraction, there's a numerator, there's a denominator. So the numerator, right? The numerator is going to go inside with the base. There. The denominator is going to go outside. So the spade is going outside. So that's the root number, and that's the power that goes inside. So that explains for these kind of, power situation. Okay. Let's do just 2 more. Okay, because I think you probably got it already by this time. Okay, or maybe this is too easy. What will show up in our homework is like, for example, the derivative, right? So for n equals to negative 1/3, right? The power can be negative 1/3. So what's the derivative of a power situation that the power is negative 1/3? Boom. Right? Negative 1/3, differentiating with respect to x. Well, this negative 1/3 will go here. Go here. Boom. Okay? And of course, what is this situation? If you write it in the power, in the root form, and that is the derivative, right? So we're going to apply that. When we apply that, we also have to apply this, right? So there's a negative, right? So it's a 1 over x raised to the power of 1/3. 1/3, right? Do you need to see a larger font? Let me see if I can make that better. Okay, x to the power 1/3, right? Or now if we apply that piece, okay, so let me bring that down to our situation here, right? Okay, so you can see b raised to the power 1/3, the spade is 3, the heart is 1, right? So that is going to be equal to the derivative of 1 over cubic root, right? The base is, the denominator 3 goes to, that's a spade, goes there. So that's the derivative of 1 over cubic root of x. Okay, let's see, let's finish. negative 3, 1/3 subtract 1, that's negative 3 under 4, negative 3 under 4. So negative 3, negative 1/3 comes with us, okay? And this piece will turn into x, whoops, I have to change it back, to 50%, okay? So x raised to the power of negative 4/3. Okay, so that's how we handle that situation, okay? Then you may wonder, how about what if n equals to negative half? What if n equals to negative half, right? So you would apply this formula, okay? N equals to negative half is going to the power part, right? And this is a negative 1/2. Everywhere n replaced by negative 1/2. Okay, whoops, negative 1/2. And in the end, we get negative half x raised to the power of negative 3/2. Okay, and on the root form, right, it's going to be derivative of 1 over square root of x. 1 over square root of x. On the other side, you know, this is an acceptable form already. But if you want to work it out to a root form, you can, which is you're gonna get negative 1/2, right? And 1 over, right? X raised to the power of 3/2, right? 3/2 is 1 plus half. So it's 1 plus half, right? Eventually, for the power 1.5, you're going to get x times root x. So if you like to see the root form, that's the root form. If you like to see the power form, that's the power form. Okay. So make sure that I trust you've been working along my side, right? So you're getting used to these different forms. So now when we are going to take a derivative, right? We're going to take a derivative. We mainly using, in this section, we're mainly using the power rule. We're mainly using the power rule, right? And using these other properties, right? The constant, the addition, subtraction. When we multiply a constant with function, right? We can pull out the constant and just differentiate the function part. For example, on number 6, right? On number 6, we got g of x, right? Equals to 7 over 4 x squared, subtracting 3x minus 12. According to the sum and differences, right? Sum and differences, we can find derivatives separately. So g prime of x, equals to, we just differentiate each part. Oh, sorry. We're gonna copy this. Okay, so I'm showing you, we're applying the addition rule, right? So this piece, we prime. And that piece, we prime. And that piece, we differentiate. Okay, we differentiate. And then what do we do? They each have a constant, right? We can pull out the constant. So this is, we apply this rule, right? Constant multiple rule. So the constant is out. The constant is out. And 12 is a constant. The derivative of a constant is 0. We can do that already, right? And then what? The next row, we can drop the 0. And what the derivative of x squared? We just did it, right? The derivative of x squared is 2x. So I'm going to substitute this piece by 2x. And what the derivative of x? It's 1, right? It's 1. Okay? And we're almost done, right? We do a little simplifying. 2 take away the 4 by 2. So we have 2 and x here minus 3. Done. Then you may say, do I have to show this much work? The answer is no, you don't have to. Okay? How much work to show? I don't expect you to show so much work. Okay, this is a G. This is how you show your work. G and G prime. You at most show these two parts. Okay, show this part. Okay, or just straight here. That's fine with me. Okay. But I do what I do here just to show you what kind of properties are being used. As you're getting better, as you're getting more and more familiar with these, and you're gonna do it in a zap. Okay, so it does not take that much. I think I think this is about 20 minutes or so. I would like to terminate this and make another one. Thank you for watching.